Given the table of values of the function f and g, we are asked to evaluate the composite of function at various x. First, f of g of 1, by definition, it is f of g of 1. Always work with the inner function first. So this is f of, to evaluate g of 1, the inner function, we go to the function g and look for the input 1. G of 1 is 2, so we replace g of 1 with the number 2. At this point, we need to still evaluate f of 2, so we would go to the function f. The input for f of 2 is 2, and the output is therefore 1. F of g of 3 is f of g of 3 equals g of 3 is 1, and f of 1 is 4. G of f of 1, first we will need to rewrite it using this notation, g of f of 1. This time, the inner function is f, so we would go to f first. F of 1 is 4. And then we would go to the function g to evaluate g of 4. G of 4 is 3. Observe that f of g of 1 is not the same as g of f of 1. F of g of 1 is 1, but g of f of 1 is 3. So the two values are not the same. This shows that the order of the composition of function matters. F of 4 is f of 4. The first notation is just a name, and the second notation is the working definition. Always evaluate the inner function first. F of 4 is 2 from the f table, and then at this point we will need to evaluate f of 2, but f of 2 is 1. G of 2 is g of 2. Always evaluate the inner function. G of 2 from the table is 4. And then from the table for g of 4 is 3.